All right. Well, hello, everyone. Thank you for coming. We're here to talk to you about OPA Gatekeeper. I am Max Smythe. I am a software engineer at Google.
And I'm Rita Zhang. I'm a software engineer at Microsoft.
Yeah, and in case no one's familiar with OPA, it stands for Open Policy Agent. It is an open source general purpose policy engine. It is a CNCF incubator level project, and it is the core of what Gatekeeper is built on.
And Gatekeeper is a customizable Kubernetes emission webhook that allows you to enforce policies and strengthen governance for your Kubernetes clusters. Now, if you operate many clusters for your company, you probably be looking for ways to control what end users can do on the cluster, and then also ways to enforce policies for the policies in your company. And you'll probably wonder, well, with all the policies that my company has to enforce, maybe they're for regulatory purpose, or maybe you just have some best practice or company best practice that you want to enforce. How would I be able to do that within Kubernetes, but still give users the flexibility and agility they love in Kubernetes? So that's the motivation behind the Gatekeeper project.
And this notion of policy in Kubernetes, it's been around for a while. Kubernetes has been around for a while. And so it's gone through a bit of an evolution over time. You could see here just an overview of the general timeline. There's a few major milestones. We call them V1, V2, V3. And over the next couple minutes, we're going to sort of go into detail of how things have progressed. So in V1, which is pretty much vanilla OPA, how they decided to integrate with Kubernetes was they created a sidecar process called kube management. And kube management would essentially follow the API server and replicate data into OPA, which was running as a server itself. And then you would register an admission webhook that would query OPA directly, and you would write your rego such that it would return a correct response, either admit, deny, whatever your use case may be. And it was originally written by Styra and is currently used by dozens of companies.
And then came V2. And at the time, it was called Kubernetes Policy Controller. Nikhil, when he was at Microsoft, he and a few other folks worked on creating the Kubernetes Policy Controller, which basically decoupled the emission webhook from OPA. And with this, he also added mutating authorization and audit functionality that we much enjoy today.
All right, so now Gatekeeper is what we're calling V3. And what's different about Gatekeeper? Well, it's essentially taking this whole notion of policy, of rego, and trying to bring KRM to it. So we are taking what you would be writing and essentially productionizing it and commoditizing it into little snippets of what we're calling constraints, which you can declare on the API server and will then be enforced. And sort of how that works we'll get into a little later in the presentation. But we do want to point out a couple of thank yous. First of all, the Gatekeeper name was donated by Replicated, so thank you for that. And also thank you to Styra for playing along and helping host the whole project.
A smeeze of regos.
Yes.
So we mentioned policies that companies want to enforce, and here are just 4 that we took as examples that we will also shortly with Gatekeeper V3. So here are some common policies that we see that companies will want to have. One is, have you ever had a question of who created created this resource. I wish I can contact them and see how I can fix that issue with the owner of this this resource. So with this policy, the admin can then ensure that all namespaces have a label that essentially has the point of contact, so that they can talk to the person if we need to do any maintenance. And then next, have you ever had an issue where you have pods running in your cluster, but they don't have resource limits? I bet some of you have run into that issue. So with this policy, you can ensure when the developer deploys their pod, you can make sure that there's resource limits. So one, it doesn't break the application, but two, it also doesn't break the cluster and affect their neighbors. The third policy that we will demonstrate is a lot of users tend to pull images from Docker and just basically anywhere, right? Because why not? So one thing that companies can actually enforce is I only want my users to pull images from approved repositories or images that have been scanned or whatever, right? So that's another policy that we will demonstrate. The last policy we will demonstrate is the ability to enforce that all services have selectors that are unique. So you don't run into the issue where you create the service, but it's actually pointing to some pod running in the production namespace.
So let's take a little bit of a step back here. We have some examples of common policies that a business might want to implement. But we need some way of translating that into a declarative form. Right, and we have some need for figuring out how to translate that into Kubernetes. So, I mean, Kubernetes, that problem is somewhat solved, right? Because Kubernetes is declarative, the act of restricting Kubernetes or usage of Kubernetes is simply restricting valid inputs to that declarative configuration. You basically limit what you can declare in a YAML. As far as making the policy itself declarative, what's interesting there is that all of these sort of limits that you may want to place on a YAML, they accumulate. I want this field to only have these certain values. I want that field to only have these other certain values, like only valid image repos, only certain labels can be applied, so on and so forth. So if you take all of those individual units of intent and call them something like constraints, and you string them together, you and them and, such that if any constraint is violated, the whole constraint is rejected, or sorry, the whole request is rejected, then you have a platform for describing and implementing policy in KRM. So what do we need to do that? We need declarative-ended constraints. We need some sort of schema, right? Because we have different styles of constraints. Either we're constraining different objects, different resources, different fields within the resource, and in different ways. Maybe there's a numeric range. Maybe there's some string matching, regex, so on and so forth. So you need different kinds of constraints that achieve these different results. And you need some way of configuring them so that you can only constrain resources in a certain namespace. And if it's a regex constraint, what regex am I matching against? You probably don't want to be diving all the way into your source code just to make a simple change as an administrator. And finally, because this is Kubernetes and because there are conventions around ownership, right? Certain objects belong in certain namespaces, and you have label selectors, names, other ways of sort of scoping down what you're interested in. There's common selection semantics. So it would be nice if our system could take care of that for us and we didn't have to re-implement the wheel every time we had a new constraint. So how that looks as far as Gatekeeper is we developed this constraint resource. And there's a couple of things I want to point out to you. The first is the kind. So here I'm calling it Kate's required labels, meaning this constraint makes sure that certain labels are always declared. The next most important field is this match field. Now, match is provided by the system, And it understands a few selection semantics right now. Currently, what you're seeing is I am matching against the namespace group version kind. And other options might be only objects in specific namespaces and label selector. And finally, in the red box here, we have the admin's intent. This is essentially the arguments to the constraint, if you think of them as functions. Right, and for this particular constraint, we have a user-friendly message. Essentially, if you do not have an owner label, we're going to tell you, hey, you're creating a namespace. All namespaces need an owner label, something that a user can understand and follow and hopefully change their request to be compliant. And then we have the actual parameters to enforce. In this case, a list of labels. There's only one, owner, and the regex we expect it to match.
And as we look at many forms of policies, one of the policies that you could potentially have is comparing information about what you're creating with other resources that are already in the cluster, right? So when you compare uniqueness of service or uniqueness of ingress controller host name, that's where when you execute the logic, the Rego logic, the actual rule inside of OPA, OPA needs to have knowledge of the data that's already in the cluster. And that's where data replication comes in. So for those type of policies, you can also replicate the data that is required to ensure that this type of policies actually work.
Yes.
And we just talked about enforcing policies. So the next feature is also audit. So we believe that it is really, really important to give admins or basically people that really care about compliance a way to see the current state of the cluster. And audit feature really provides that. So with the audit feature, we can periodically run and evaluate the resources that exist in the cluster against all the policies that are enforced. And this basically allows admins the ability to ongoing monitor their cluster, make sure they're actually in compliance, but also give them a way to detect and remediate any issues that currently have with any of the pre-existing resources in the cluster. And in order to have the audit feature to work, the objects that are audited needs to be replicated once again into OPA. And the actual results of audit results are actually exposed in the status field. So as you can see, as Max mentioned earlier, this is an example of a constraint that already exists in the cluster. And when we run the audit periodically, every few minutes or seconds, depends how you want it, the violations are then listed, appended to the status field, as you can see here. And the time at which this actually failed is also stated in the constraint itself.
Yeah, so far so good. We know what we want to do. We know how we want to enforce things. There's admission webhooks and there's audit. But we're still missing some key pieces here, right? How do we tell the system the sorts of things we want to enable an admin to do, right? How do we code that behavior? How do we inject it into Rego, into OPA, the gatekeeper system, what have you? And this boils down to two critical components, right? There's the input schema that you're expecting the admin to provide, that parameters field. And there's the actual source code that does the checking, the Rego, right? So there's some way we need to bundle them together. And so what we're going to do, essentially, is we're going to come up with a concept of a constraint template. And we're going to provide exactly those two things. One thing that we don't need to provide, thanks to how everything is wired together, are the matching semantics. So as Kubernetes evolves, as new ways of selecting resources come into being, we don't need to go back and update our validation. We just get that extra scope for free. So here's what a constraint template looks like. It's a lot. But essentially, at the top, in the spec, you have a skeleton of a CRD. And the biggest two things you have are the names for the CRD that then become the name of the constraint resource, as well as this validation field. And the validation field is an OpenAPI v3 schema, and it gets ported directly into the parameters field of the constraint. So you can control what admins can put into your constraint and make sure that it's type safe. Now, at the bottom here, we have the targets field. Now, targets, all it does is package Rego for you. You can see here I have Kate's required labels package, and there's a deny rule. How this all works is the deny rule is the entry point, and you can have as many of those as you like. In this rule, you can have other helper functions, other helper rules to do your evaluation. But Gatekeeper, when it performs a request, if there is a matching constraint, it's going to check the deny rule for the constraint templates. And if it matches, if message is returned, that message is going to be perpetuated down to the end user, and the request is rejected.
So this is actually really, really cool, because in the past, you would have had to write your own emission webhooks, but also, even with previous version of Gatekeeper, you would have had to write your own Regos and your own config maps. So with V3, now Gatekeeper provides a mission system that allows you to just configure rather than writing code, but also to write policies and rules as constraints. And the constraints can also be parameterized, so you only have to write the Rego, the template once, and then give to other folks to actually parameterize. And this is really scalable, but also extendable and easy to share, easy to test, and you can actually share it internally or with all your friends in the community. But last but not least, it's not just for Kubernetes. You can also integrate this with your CI/CD pipeline.
Right. So this is all very abstract. I thought it'd be fun to, or we thought it'd be fun, to bring it into a little bit more concrete of an example. We have an organization called Agile Bank. They're a fictitious organization, and they have a few issues, and we're going to see how Gatekeeper helps solve their problems. So, in the beginning...
All the banks, right? Come on, people.
We have our developer.
So I'm a developer, and I'm going to go ahead and create, wow, sorry. I'm going to go ahead and create some a namespace to be used for my workload. And
5 weeks go by. The developer moves on to another project. Advanced transaction system is long forgotten until our intrepid admin finds it. What is advanced transaction system? Do we use it? They go on a 3-day quest across many departments, only to find the project was scrapped. Never again, says the admin, as they delete the namespace. So they delete the namespace, they search for a solution, they find Gatekeeper, install it in their cluster, and they look around, they find a few templates that I think, as the admin, might be helpful. I see there's one that allows me to restrict repositories, one that allows for container limits, or one that makes sure you have container limits supplied, one that allows me to require people supply certain labels, and one that makes sure that all service selectors are unique globally across the cluster, just in case, so I don't point, say, production at dev. All right, so I'm going to load those into the system by running kubectl apply templates. And then I'm going to write out some constraints for each of these templates. I'm just going to quickly look at one of them. This is that label constraint that I showed you before. All the rest look kind of similar. There's selectors that are appropriate, and there are parameters. So I'm just going to apply all of my constraints, get them enforced, and hand it back off to the developer.
Now I go back to the system and deploy things like I normally do. So I'm going to create a production namespace, and looks like I'm not really allowed to do so without telling my admin who I am and how to contact me. So then I update my deployment YAML and add my name there, and I apply, and then everything works. Next, I'm going to deploy some pod. And like a good developer, I did not specify any resource limits. And here, prior to this, I would have had no idea, and then it would take days, maybe even longer, to get that fixed. So now I'm going to apply some limits. And of course, I was very ambitious and add too much. And this lovely, helpful message actually tells me what the admin would like to do. So next, I update that, and it looks like many developers, I used my own image when I should have used a production one. And let me go ahead and update that, and wham, that worked. Oh, sorry. Another service for my application, so I can actually give this endpoint to the front-end developer. And as you can see, I mistakenly pointed to the Gatekeeper system namespace when it's only for test. Now, prior to this, I would probably break the whole thing and then call the admin to help me fix it. But luckily, with this lovely error message, I now know that I made a huge mistake and then update it to do the right thing.
All right. So the developer was able to self-instruct on our policies and get everything done through self-service, which is really helpful for me as an admin. I now have a lot more time to focus on the policies that are actually helpful and making sure that our cluster is reliable and other good admin stuff that isn't purely policy enforcement.
And I can deploy my changes without having to wait for the admin to tell me what he expects me to do.
Feels good not to be a bottleneck. All right. So, all's well until the big outage. The bank is down for hours. Now, I had no idea there were resources in the cluster that had no container limits. I thought I took care of that with my policy before. But that was why, right? Something got hungry, ate up all my cluster's resources. So we need to fix that. We did. But what else is lurking, waiting to attack in terms of resource limits? Well, we could look at audit. So let us look at the container limits constraint. Ah.
That's a lot of bad deployments, sir.
Yeah.
Who did this?
It is. Fred.
Must be Fred.
Fred.
Yeah.
Blamelessly, but Fred.
We don't blame anybody.
Yeah. And that's the end. Of the demo, not the talk. All right, so where are we in terms of the project? What's the status?
So the Gatekeeper project is currently at alpha, but our plan is to release the beta version of it at end of June. And we're here to talk to you about it and to get more feedback from you after you start using it. We would love for more contribution, but please tell us your use cases. And as you use this, does it make sense? And tell us the user experience. So we would definitely love to hear your, more feedback.
Yeah. You said June? At the end of June?
Yes.
Yeah, we're looking for beta? Yeah. All right, so, and we have all of what we have here. It's currently working, but where are we looking to go next? One of the big use cases we're looking to provide is mutation. We want to do the same kind of thing we've done with validation constraints in terms of packaging them up, making them reusable, declarative, all that nice stuff. We would also like to be able to more easily incorporate external data into the system. So think about validating that owner constraint against the actual users of your system, right? Actually look up real usernames instead of relying on a regex. Authorization is possible. It would likely go into a different project because it shouldn't be running on the cluster directly. And it will have slightly different semantics, but the same general idea, constraint template constraints. More audit features. We would like audit. Right now, it's very useful as a debugging tool, very useful for keeping an eye on sort of what's happening in the cluster right now. It's not writing out to, say, signed logs. It's not writing out very granularly such that you can view a historical a historical timeline of what has been in and out of compliance in your cluster over time. Metrics for Prometheus, so you can instrument and alert against the project. View things like, oh, there's a lot of rejections happening, what's that about? Or just, this thing is behaving in a weird way. Developer tooling to help people write constraints. We want to make it easy for people to build things and share so the system can continue to evolve as Kubernetes evolves. And finally, dry run, so that when you're developing new constraints or testing them out on your system, you can see how it's going to interact with your current production environment and developer requests before actually enforcing them to make sure that it's not going to be a big thing to suddenly be denying certain issues that people are commonly engaging with. All right. And we would also like to thank a lot of people, particularly the open policy agent community, definitely Replicated for giving us the Gatekeeper name, and not least Tim and Torrin of Styra for hosting the project and helping along with development and with the slides. We really appreciate it. And please join us. We would love to have you. Here is our GitHub repo. We are on Slack, so please join our channel, ask us questions, and if you want to help participate, we have a meeting every Tuesday at 2 p.m. Pacific time. We're open to changing that. I realize that's something like 10 p.m. in the current time zone, so 11 maybe even, and sometimes. So yeah, definitely we can make that earlier.
The end. Questions?
So what I'm hearing, I'm going to paraphrase, correct me if I'm wrong, is are there scale problems with audit if you have a very large cluster or a lot of constraints? Essentially, what I'm hearing is, will the system kind of take a nosedive because it's auditing periodically? So that is a good question. And for very large systems, we're going to make it possible to separate out the audit from the admission so that they're running on two different systems and one will not have a performance impact on the other.
And also one of the knobs that you can tweak is list how many violations per constraint. So with that, it will basically only give you like the ones that the number, the limit that you've set, right? So like top 20 or top 10, whatever. So in theory, it shouldn't give you a really, really long list. So.
So the question is, can you prioritize rules and make it kind of sequential and make sure you get the most important ones for audit specifically?
No.
Not currently.
Remember what he said about and, right? Like, if you do that, it would kind of defeat the whole purpose, I think.
For validation, for audit, it may be possible to kind of.
We never talked about this.
Yeah. But
But see, this is why your feedback is really important. Yeah. Hi. So I'm going to repeat the question. Let me know if it's, yeah. So the question is there rollback, right? if there's a policy deployed and if you see a problem, can you roll back? Oh, rollback of the policy.
So are you talking about bad Rego source code, or are you talking about the admin pushes a bad parameter, or? The admin left a 0. All right, so it has the same sort of rollback capabilities as standard KRM, which is you get what you bring to it. If you're using GitOps, which we think this would work very well with, then you could roll back through that vector.
Yeah, and this is also why we want to add the dry run functionality so that you can try it before you enforce it. So that if you left a 0, and you would know before you actually enforced it, right? Does that answer your question?
So you want to have the templates outside of Kubernetes, but enforce them in Kubernetes? Interesting. So we definitely thought about, for like a CI/CD pipeline, reading the templates in, not from the API server, so you could validate the state of your cluster with that. I think it could be possible. It's not currently something we're supporting, but you'd need to make it available via a webhook.
Nothing prevents you from creating it, like creating something that creates the constraints, right?
So this is like a multi-tenancy question. Okay, so the question is if you have like tenants in the cluster and you have like an Uber admin in the cluster that really has like root privileges to control what people do. I think that would depend on your multi-tenancy model, right? If you're using namespaces as the granularity for tenancy controls, I would say one of the things we're looking at is making every constraint both a cluster level resource as well as a namespace scoped resource. And then the root admin could modify the cluster level. And also, eventually, I would like to see constraints sort of being able to be grouped together and clustered by actually the admin role that would be interested in them. Like maybe you have certain labels that are important for billing, others that are important for like data management, and then you could scope out and delegate admin privileges based off of like the RBAC for the style of admin.
By the way, Azure Policies does this today. So.
Question about the life cycle of this constraint template. So you create constraint template and then you modify. So it's the controller creates custom resources from the scratch. What with existing constraints that are already created, what will happen if you change the schema, for example?
So it's a life cycle question of what happens in constraint templates. So there's constraint templates create constraint CRDs, which then people can create constraint custom resources. What happens if a constraint changes and then a pre-existing constraint, say, has an invalid schema after the fact? So functionally, what happens right now in Kubernetes is the constraint continues to exist in its previous form. And effectively, what is going to happen for evaluation at that point is that likely that constraint will no longer match. Like it'll get, the rule will set an undefined state in Rego. So that violation will kind of go away. So the kind of convention that we're suggesting around that is you can version constraint templates within the name of the template and go v1, v2, and keep the same kind of Kubernetes version implications that exist for like alpha, beta, so on, where you make sure that you keep your interface consistent if you're just doing like transparent upgrades of the Rego.
Another question about how do you ensure that these all constraints really work in different, you can have different settings for different namespaces, for example, so different rules. Is it possible?
Yes, yes. So this is part of the matching semantics. So the question was, can you have different rules for different namespaces for constraints? And one of the things you could do with constraints is you could have namespace name as the matcher, so that only resources within a given namespace will be matched against that constraint. It's potential, we don't have it right now, but essentially a namespace selector, so a label selector that selects against namespace labels would be a more general way of doing it if you're trying to like cluster namespaces together in a more dynamic fashion. Cool. Any other questions? So the question,
I think you're saying when you deploy deployment, make sure there's a service attached to it. Like have a policy that requires service as part of the deployment.
So that's interesting because it's an ordered constraint, because the Kubernetes API server, like order is not necessarily preserved in the eventual consistency model. That being said, you could definitely have a constraint on a resource that looks up a different resource, and if it doesn't exist, and you have some way of figuring out the resource you'd expect to see, right, like a label selector against cached resources, then you could do that, yes.
But that's assuming the service already exists. He's saying he wants to make sure a service is a part of the deployment.
Okay.
Right? Okay.
A service is...
When developer is creating a deployment, he should also create a service for this deployment, not simply deployment which is not transferred.
Oh, okay. So the thing you want to check is the thing that has the reference. Yeah, you would need to create the deployment first at that point.
You can use a Helm chart for that.
But yeah, if you were to create deployments, cache those using the sync CRD, then when you deployed the service, you could check, or I think I may be getting the kinds backwards, but essentially that's the model. You can reference.
But I think the short answer is no, right? Like what he wants, right?
No, I think it's yes. So the selector is on the sorry, I'm blanking on, so it's deployment and service. Right, the selector is on the service. So if you're caching services, you can then run the selector logic against all cache services. Or sorry, you can take all cache services, get their selectors, run the selector's logic against the currently proposed deployment. And if it doesn't match any existing ingress or service, then then it'll fail. But it's a new service. Right. So, yeah. Any other questions? Sorry, I heard the tiered bit of the question. I would like to get it to that state. The question then would be the RBAC permissions around that. right? So if you are in a state where you can find a trusted group across all those departments that you feel should be allowed to hit all policy everywhere, then it would be fine for now. Really, the next step would be to create a set of resources that, for instance, limit the set of labels you can touch and just delegate those, right? And that would be the less trustful shared responsibility model. Any other questions? All right. Well, thank you all very much for coming. We appreciate your time.